So at this point, we've looked at many different types of functions. And before we go into the last type that we're going to be studying, trigonometric functions, I want to go back and sort of review each of these functions and things that work for all of them. So we're going to look at transformations of functions next. Now, what does that mean? Transform means to change. So we're looking at how we can take a function and change it in different ways. So for functions, we can change three things. We can change the orientation, think of orientation as how it can be rotated. So for example, if you have a rectangle, you can make it so that the short side is on the top, or you can make it so that the short side is on the side. So, on the left and the right instead of on top and bottom. That would be the orientation. The location. So think about where it is on your paper. Or the shape. So taking a rectangle and turning it into a square. And we have rigid and non-rigid transformations. So a rigid transformation the shape will not change. There are lots of different types of transformations, but we're going to be talking about the basic three. So you can combine these three, but we're talking about the fundamentals. So types of transformations. We have reflection. We have translation. Don't confuse translation with transformation. Translation is a kind of transformation. And we have dilation. So reflection is rigid. This is the one that changes the orientation. Translation is also rigid. This is the one that's going to change the location. And dilation is the one that's non-rigid because it changes the shape. We can always combine these to change more than one thing. Now in this video, we're going to concentrate only on reflection, and then in future videos, we're going to talk about translation, dilation, and then putting it all together. Okay, so let's start with reflection. We have different types of reflection. 4 different types. We have reflection that we're going to talk about, okay? So we have reflection in the line y equals x. This we actually already talked about. We have reflection in the y-axis. Reflection in the x-axis. And reflection in the origin. Okay, so we're not going to spend a lot of time on reflection in the line y equals x because we already talked about it. So we'll revisit it for just a minute, just to remind you. A reflection in the line y equals x is its inverse. As long as it's a one-to-one function, right? If it's not a one-to-one function, then it's still a reflection. It's just that we don't call it an inverse. And as a reminder, to reflect in the line y equals x, we just switch x and y. And solve for y. Sometimes that's really simple, like in any sort of linear function. Sometimes it's more complicated in quadratic. If we were to do that, we would get a reflection. It's just that our reflection wouldn't be a function. In cases like that, it might be easier just to take lots of different points and switch the x and the y values of each of those points. And that's how we could get the new graph, since we already know it's not a function. Okay, so we're not going to concentrate on that really. Let's discuss reflection in the y-axis next. Okay, and just as an abbreviation, when we do this, we're going to use a capital R to represent the idea of reflection. And then as a subscript, we're going to write y-axis. And the best way to do this is to look at points. So let's just look at a graph. And let's think about what would happen to a specific point. So here's your y, here's your x. Let's say that we take -3, 6. If we were to reflect that in the y-axis, what we're doing is we're saying, okay, the y-axis is acting like a mirror. So if we look towards the other side and we go the same distance from the y-axis, what's our new point? Our new point is 3, 6. What does this mean? This means that if we have a point and we call this our xy, then our reflection would be -xy. And if instead we called this point xy, then our reflection would be on the other side, and this would be -xy. In other words, to reflect in the y-axis, you keep the y the same because we're not changing. Think of it as the height of the point. We're not changing the height of the point. What we're doing is we're changing its location on the x-axis, right? We're going from either to the left of the x-axis to the left of the y-axis, and then moving towards the right, or we're going from on the right of the y-axis and we're going towards the left, because we're treating the y-axis like a mirror. So imagine you're standing in the mirror and you're facing the direction of the mirror. So you're pointing your feet towards the y-axis, okay? So you would keep y the same. And change the sign of x. So let's just review the function notation, okay? If you have f of x, the x is just your x value or your input. This becomes important because you are using the function notation, the f of x. You're using that to help you write the new function, okay? The function after you reflect in the y-axis. F of x altogether is your y value or your output. Okay, so again, if you do a reflection in the y-axis, we know from the points that the point x comma y is going to become negative xy, which means that the sign of the input changes. So if you have f of x, it's the x value that changes, your input that changes. So the new notation would be f of negative x. And we know from composition of functions, what does this mean? All our x values become negative x. And this is how we can find the new function. Okay, it's just a composition of functions. So let's just take a bunch of examples. If we have f of x is equal to x squared plus 1. In each of these cases, we're going to reflect in the y-axis. What does this mean? F of negative x is the same thing as negative x squared plus 1. We took our x and we replaced it with a negative x. That's all that's happening. I'm going to write down a bunch of functions and we're just going to reflect each one in the y-axis. So let's say that we have f of x equals x plus 8 squared. F of x equals x cubed minus 6x plus 1. F of x equals 2 to the x plus 3. F of x equals the log of 6x minus 4. And f of x equals x plus 2 over x squared minus 6. So just a bunch of different functions. And for each one, we're going to reflect. in the y-axis. So that you can see what it looks like with a reciprocal function, logarithmic function, exponential, polynomial, quadratic. You're seeing what it looks like in every case. So in each case, let's find f of negative x. Well, this is saying take every x and replace it with negative x. So we have an x, which now is negative x, plus 8 squared. You should now do this on your own. You should pause the video, do the remaining 4 functions, and then start it again and see if you're getting it right. So here, f of negative x, we're replacing each x with a negative x. So we have an x cubed. That becomes, instead of x cubed, negative x cubed. Minus 6x, so minus 6 times negative x. I'm not simplifying these because, well, this one I'll simplify. And then a plus 1. Negative x cubed, the negative stays because the negative cubed is just still a negative. Negative 6 times negative x becomes, I forgot about the cube, sorry. Negative 6 times negative x becomes a plus 6x and then plus 1. Okay. It can be helpful to simplify because later on when we do more than one transformation, you might want to simplify. Here, f of negative x, well, we see 2 to the power of x plus 3. So now it's 2 to the power of negative x plus 3. Here we have log. So log of 6 times negative x minus 4. And again, just to make your life easier so that you don't have as many parentheses, this becomes negative 6x minus 4. 6 times negative x is just negative 6x. Here, every time we see an x, we're going to replace it with a negative x. We have an x plus 2, so it becomes negative x plus 2. And then we have an x squared down here, so it becomes negative x squared minus 6, which is just negative x plus 2 over negative x squared is just x squared. Okay. So that's a reflection in the y-axis. And if you forget, just think about what a point would look like. Let's talk about a reflection in the x-axis. We'll do this in, I want it to be in a color you'll see. Let's do it in brown. So again, it's a capital R, and then the x-axis is a subscript. So think about your graph. I always like to think of points to help. So if you have the point 3,6 here, and we want to reflect it in the x-axis, that means that we're going to face the x-axis. And when we go to the other side, it's equidistant. And our new point, the x stays the same, the y is what changes. So if we have a point x comma y, the new point instead of the x changing, it's going to be the y that changes. So it's going to be x comma negative y. Okay, so what does that mean? That means that this time it's the y that changes. Well, f of x is our y value, right? Not just the x. We want the whole y to change, and the whole y is our f of x. So f of x becomes negative f of x. Now I want you to notice something. A change in the x-axis, sorry, a reflection in the y-axis is a horizontal change. We're moving horizontally. When we move horizontally or we make any sort of horizontal change, then what we're doing is we're affecting our inputs. We're affecting our x values. This is a vertical change. Anytime that we make some sort of vertical change, we're affecting our y values, and f of x is our y. Okay, so let's just write that down. That's true for all transformations. So any horizontal change will change the x values. So for example, a reflection in the y-axis changed x to negative x. Any vertical change will change the y values. So for an example, the reflection in the x-axis was a vertical change. It changed f of x to negative f of x. And this is true for all transformations. So this is true for reflections, it's true for translations, it's true for dilations. So use this to help you anytime that you're not sure how it works. Okay, so let's go back to reflections in the x-axis, and we're going to do exactly what we did with the reflections in the y-axis. I'm going to go through each of the functions that we did before, and we're going to just reflect them in the x-axis. So again, a reflection in the x-axis says your x comma y becomes x comma negative y. We figured that out by thinking of points. And that's always going to be true. We're going to use points to help us here, which means f of x becomes negative f of x. So I'm going to put a bunch of different functions, same functions as we used before, just so that you could see the difference. So we have f of x equals x squared plus 1, f of x equals x plus 8 squared, f of x is equal to x cubed minus 6x plus 1, f of x equals 2 to the x plus 3, f of x equals the log of 6x minus 4. F of x equals x plus 2 over x squared minus 6. And let's actually add one in because we didn't do an absolute value function. So the absolute value of 2x minus 4. Okay, and for each of these, we're going to be reflecting in the x-axis this time. And what this says is take your entire f of x and put a negative in front of it. So not just the x, but the whole f of x. So if you think you know how to do this, stop the video now, check it out. If you're not sure, then stay with me for 2 or 3 examples and then do it yourself. Okay, so for all of these, we're going to have negative f of x. And what this says is, essentially, take your whole function, put it in parentheses, take your f of x, and put a negative in front of it. And that's it. And then we can simplify. Again, you're not always going to have to simplify, but particularly if you're working with more than one transformation, it can be helpful. In the next one, we have negative f of x. Again, your whole thing is in parentheses already. Whether you put parentheses around this or not doesn't matter because exponents comes first. So you could just put a negative in front of this. And this might be a case where you would just leave it like this because simplifying, you have to square it. You have to do x plus 8 times x plus 8 and then multiply that by a negative 1. You might say it's not worth it. Let me just leave it, okay? This next one, again, you're putting your whole function in parentheses. And then you're putting a negative in front of it. And this one is easy enough to distribute. So this would be a case where you would simplify because it's easy enough to simplify. Again, the previous one, squaring comes before multiplication by negative 1, so we don't have to put parentheses. This one, same case. 2 to the x plus 3 would do 2 to the x plus 3 first anyway, so you don't need parentheses. If you're not sure, put the parentheses in there. But you would just put a negative in front of this. Here, log of 6x minus 4. Just put a negative in front of it. You have to do log first. Log is like an exponent. Negative f of x. Here you have x plus 2 over x squared minus 6. Put it in parentheses. Put a negative in front of it. Here, the absolute value sign acts like parentheses. You're taking the absolute value of 2x minus 4, so you don't need extra parentheses. So you just put a negative in front of it. So you're just taking your whole function and putting a negative in front of it. Okay, the last one, a reflection in the origin. We could do that in purple. So the origin is the point 0, 0. Okay, here we can draw our graph. Again, use your points to help you. So if we were to take the point 3, 6, we're reflecting in the origin, so it's as if we stand on 3, 6 and we point our toes toward the origin. If we do that, we're going to be equidistant on the other side. So we're going to form a straight line. And this would be the point -3, -6. So notice our numbers are the same because we have to be equidistant. What does this mean? This means that any point x, y, doesn't matter where we are on the axis, any point x, y, if we point our feet, point our toes to the origin, then the point on the opposite side is just going to be -x, -y. So x, y becomes -x, -y. Or if we think about f of x, it's -f of negative x. What does this mean? A reflection in the origin is equivalent to a reflection in the x-axis and y-axis. Okay, so you're essentially doing both. You're doing a reflection in the x-axis and then you're doing a reflection in the y-axis. And you can do it in any order that you want, okay? It doesn't matter. I like to reflect in the x-axis. I like to reflect in the x-axis first, but that's just a personal preference. It's kind of up to you. So let's do the same thing that we did before. Let's take all of our functions and reflect in the origin, okay? And you can do it simultaneously or you can do it one at a time. I'll show you both, okay? So let's take f of x equals x squared plus 1, same functions. F of x equals x plus 8 squared. F of x equals x cubed minus 6x plus 1. F of x equals 2 to the x plus 3. Notice it doesn't matter what kind of function it is. Everything that we do is the same. Log of 6x minus 4. So if we put a negative in front of x plus 8 squared, we're also putting a negative in front of log of 6x minus 4. It makes no difference that it's logarithmic versus exponential versus quadratic versus reciprocal. F of x equals x plus 2 over x squared minus 6, and we'll also do the absolute value. Okay, and again, you can start this on your own, and if you get stuck, start the tape again, or stick with me for a couple of examples and then do the remainder on your own and just check. So a reflection in the origin, you can do them both at the same time, or you can do it one at a time, okay? So let's say that we did this one at a time. So a reflection in the origin, what we can do is we could start with a reflection in the x-axis and then do a reflection of that in the y, okay? So we could say this is a reflection in the x so the reflection in the x is negative f of x, which we know from previous ones is negative x squared plus 1. Then from here, we can do a reflection in the y-axis, which we know, so now this is negative f of negative x. So we reflected in the x, which was a simple reflection. We take the whole function, we just put a negative in front of it. Now we're going to reflect that function in the y. I don't know why some of this isn't coming out. Okay. To reflect a function in the y, you're going to take every x and you're going to make it negative. But instead of looking at the original, we're going to look at what we already reflected. So this becomes negative of negative x squared plus 1. And this is where simplifying could be helpful. That's up to you. Okay, so you could do this at the same time or you could do it separately. Let's do this next one. Let's do it the other way around. So let's do a reflection in the origin, but this time let's do a reflection in the y-axis first. So we're going to do f of negative x first. And if we do that, f of negative x, and you can go back to the previous pages, says take the x and replace it with a negative x. So we take the x and we replace it with negative x. Now we're going to do the reflection in the x-axis, which says put a negative in front of the whole function. But instead of going to the original, we're going to go to this one. So we just put, it would just have like parentheses around it and a negative in front of it. And this doesn't need extra parentheses because the square comes before the multiplication by -1. Okay, or we could do this both at the same time. So let's do that with the other ones because this is extra. It's kind of like doing extra writing for no reason. So negative f of negative x. If it helps, put your parentheses with the negative in first, because you know you're going to have to do that. Okay, now we're going to go to the function and we're going to replace every x with a negative x. This was x cubed, it becomes negative x cubed. Minus 6x, now it becomes minus 6 times negative x plus 1. And we're done. Now we have negative f of negative x. This is an exponential function, so you could just put the negative there, but if you're not sure, put in the negative with parentheses. There's no reason for you, it doesn't matter. It's just, you don't need them in this case because order of operations says you're going to do 2 to the x plus 3 anyway first. So now we have 2, and instead of x plus 3, negative x plus 3. So this negative here says take your whole, do a negative with parentheses. Inside the parentheses, you're going to have this, replace your x with a negative x. So here, negative f of negative x. Take a negative, put parentheses, log of 6 times negative x minus 4. So you're essentially doing a negative and then going back to reflection in the y-axis and just sticking that function in there. Negative f of negative x. Negative, parentheses. Replace all of your x's with negative x's. Negative x plus 2. Then we have an x squared, so it becomes negative x squared minus 6. Negative f of negative x. Here, our absolute value acts as a parentheses, but again, if you're not sure, stick a parentheses in there. You can always have parentheses. Absolute value of 2 times negative x minus 4. And you're done. That's it. Okay, so before we stop, there are 2 types of functions that deal with reflections. So I want to just talk about those 2 functions briefly. So the first thing that we have is an even function. So all functions can be described as even or odd, or neither. Just like all numbers can be described as even, odd, or neither. So we could have functions that are neither. So we're going to talk about functions that are even or odd. So an even function. An even function is when the function is the same when we reflect it in the y-axis. What do we mean by this? If we take f of x, it is the same as f of negative x. Examples of even functions. If we have f of x equals x squared, okay, notice f of negative x is negative x squared, so we're replacing our x's with negative x, which is just x squared. So f of x does equal f of negative x here. If we had f of x equals x squared plus 3, well, f of negative x is negative x squared plus 3, which is the same thing as x squared plus 3. So once again, it works. Okay, this is happening because when you square a negative number, you get the same number back. Okay, you get something positive. If we have f of x equals x to the 4th plus 5, same thing happens. F of negative x, you're replacing your x with negative x, so you get negative x to the 4th plus 5, or x to the 4th plus 5. These are the same. These are even functions. If you think about it on a graph, some examples of even functions, what we're saying is the reflection in the y-axis is the same. Sorry, in the y-axis is the same. So a graph like this. Another example would be a graph like this. Notice I'm just using the y-axis as a mirror. So here's our x, here's our y, here's our x, here's our y. So any function for which the y-axis is a line of symmetry, is an even function. Okay. Then we have an odd function. So an odd function is when the function is the same when we reflect it in the origin. In other words, f of x is equal to negative f of negative x. Okay, so an example of an odd function. F of x is equal to x cubed. So for this one, negative f of negative x. Well, this is negative of negative x cubed. Negative x cubed is negative x cubed. And the negative of that is just x cubed. So both of them are equal to x cubed. So an example graphically, I'll give you two. I'll try to give you two. These are a little bit harder to graph. Here's one. And here's another. Okay. So in other words, any function for which the origin is a point of symmetry is an odd function. If neither of these is true, then it's not odd and it's not even. Okay. And just a quick note that I think is important. A function, we talk about symmetrical in the y-axis and symmetrical in the origin. A function can't be symmetrical in the x-axis, because if it is, then you have a point on it above the x-axis and below the x-axis. It fails the vertical line test. It's not a function. Okay, so let's just write that down. So a function will never be the same when you reflect it in the x-axis. Okay, in other words, f of x will never equal negative f of x. Because that would mean the x-axis is a line of symmetry. It would fail the vertical line test. And is therefore not a function. Perfect example. If you have a parabola on its side, which is actually called a paraboloid, fails the vertical line test. Okay. And that is it for reflection. So in our next video, we're going to do translation.